Okay, someone on the mic can see the textbook?
Can see, teacher.
Okay, thank you. Okay, so this one will be 8.2. Okay. So this chapter actually is quite, not to say very long, but okay. Then after that we have 8.3, then finish already. Okay, so I don't know whether today I can finish this 8.2 or not. Okay, so let us start. Okay, so write the index for today. Okay, still using the same book. Today is 6. Okay, addition and subtraction of vectors. Okay, so yesterday I do ask whether you have learned resultant vector in your physics or not. Then you told me that this is the first time you heard of a resultant vector. Okay, so resultant vector actually is you combine two or more vectors lah. Okay, I give you one very simple example. And then this question also always will come out in the exam. Okay, example, you want to swim, okay, across, this is a river, this is a river, okay, so you want to swim from here, okay, across the river, go to the other side. Okay, if your direction, your own direction, okay, let's say is the A, the vector A. Okay, but remember, because this is a river, okay, so the stream will bring you, okay. Example, this is the upstream and this is the downstream. So the flow of the stream will be something like this way. This way. Okay, let's say it's the B. So at the end, okay, if you are swim in this direction, you will not reach here. Okay, because of the stream flow bring you downstream a bit. So at the end, you will end out to reach here. Okay, so this is we call the double arrow is the combination of these two vectors. So this is the one we call it resultant vectors. I think it's quite simple lah. Okay, so I can say A and then plus the B, okay, will produce this. This one I can label it as A plus B. Okay, so this is the resultant vector. Okay. This is another example. You look at this inquiry 2. Okay, I hope you have gone through it because yesterday I tell you to go through it. Okay, they give this example. Okay, here actually they give 4 people here, Dayang lah, Miang lah, okay, Tan and Ranjit lah. Okay, so this one they show Ranjit's one. Okay, where is Ranjit's house? Okay, Ranjit's house is here. Okay, they want to go where? Okay, they want to go to this mini markets. Okay, this shop. Okay. You can't straight away from here to go here because there's no route. Okay, so you have to take this. Okay, take this route. Okay, and then continue with this route. Okay, so this is one vector, this is the other vector. Okay, when you combine these two, the resultant vector will be this way. Okay, so the resultant vector is like, the shortcut. If happen that this is a route, okay, so the resultant vector is the shortcut of it. Okay, you direct from the starting point and then go to the terminal point. Okay, but in case this is not a shortcut, you cannot follow this shortcut, you have to follow the normal route, then you have to take this and this. Okay, means this vector add with this vector. Okay, so the resultant vector is the shortcut. Okay, this is another example, okay, of the resultant vector. Okay, so you see what is the definition of the resultant vector? Okay, this one you can write. Okay, resultant vector is a single vector that is produced from addition of a few vectors. Okay, so it's a quite clear cut. Okay, now we look at all this case. Okay, here you have a case 1 and then case 2. Okay, case 1 is for a parallel vector. Okay, then case 2 is for non-parallel vector. Okay, Case 2 is here. Okay, non-parallel vector. Okay, we come back to case 1. Okay, addition of a 2 parallel vector. Okay, so here you see from here to here. Let us count 1, 2, 3, 4. Okay, means one small, this box is A lah. So 4 boxes here is a 4A. Okay, plus, okay, same directions, same direction because it's positive 4A and positive 5A. Okay, same direction, but here now is 1, 2, 3, 4, 5. Okay, starting point, ending point, 1, 2, 3, 4, 5. Okay, 5 boxes. Okay, so all together will become 9 boxes. Okay, and then follow the same direction. So it's positive 9A. Okay, if using magnitude, the same thing. Okay, subtraction. Okay, look at this. Okay, so 7B, okay, minus 4B. Okay, actually 7B, you can write it as plus a negative 4B. Okay, negative 4B is in another direction, this direction. Okay, so altogether will become 3B. So you just actually very simple. You just minus as usual, as your vector is like a variable. Okay, like example, you are doing 7x minus 4x. Okay, do the same thing. Okay, so you get 3x, right? So here you will get 3b. Okay, but the concept wise is like this lah. Okay, so you say that the magnitude is the same. Okay, the magnitude for the 3b is equal to magnitude of the 7b minus the magnitude of the 4b. Okay. Okay, so this one, okay, same as this. Okay, for a minus b, you can write it as a plus negative b. Okay, because we can't see what's the meaning of minus, but we can see the addition part. But we also understand what is the meaning of negative vector. Okay, means have an opposite direction with the positive vector. Okay, so for the minus, okay, you can write instead of a minus, you write as plus but a negative vector. Okay, so this one you can write it as your notes. Okay, so that's simple for the parallel vector. Okay, now we come to a non-parallel vector. Okay, for non-parallel vector, there are three ways of doing it. Okay, actually only 2 ways lah. Okay, because actually the polygon law actually is from the triangle law. Okay, it's just a polygon law. Why we have polygon law is because we have more than 2 vectors combined. Okay. Okay, so now we start with triangle law. Actually, there are two laws on it: triangle law and parallelogram law. These two are totally different. Okay, but the polygons law, which is the C1, actually is from the triangle law. Okay, polygon law is more than 2 vector we combine. Okay, now we start with a triangle law. Okay, triangle law for addition of a 2 non-parallel vector is given as AB plus BC is equal to AC. Okay, so you see AB is here. Okay, and then BC is here. Okay, same like just now I give the example for resultant vector. Okay, so you see from A you go to B, then from B you go to C. The shortcut is from A, okay, final you reach C. Okay, so you can draw from the A go to C. Okay, the longer way, the longer path that you separate into 2 is you go from A to B and then B to C. Okay, so you have to see for this journey, what is your starting point, A, and then what is your ending, the final ending point, C. Okay, so you draw from A to C will be your resultant vector. Okay, this one we call it triangle law. Okay, because it will form a triangle. Okay, then you have to remember A to B. Okay, for the first vector. Okay, B will be the ending point for the first vector. Then B will be the starting point of the second vector, and then continue. Okay, I repeat. Look at this. The B and the B here. okay, this B will be the ending point of the first vector, and this B, the same B, will be the starting point of the second vector. Okay, then what is the resultant vector? Okay, take this and this. Okay, mean the starting point of the first vector and the ending point of the second vector will be your resultant vector. Okay, I hope it's clear. Okay, so that you don't have to draw. If the question didn't ask you to draw out the resultant vector and the two vectors that form the resultant vector. Okay, you just look at this. Okay, B and the B. Okay, make sure B and the B, this one at the side. Okay, and then the resultant vector will be the AC. It's simple. Okay. Okay, then this triangle law can be used for subtraction of two non-parallel vector. It's the same thing. Okay, you just have to write the subtraction as the negative the vector. Yeah. Okay, you can look at this. A minus B. Okay, here is the A. Okay, B is this way. Okay, but for the A minus B, instead of writing A minus B, I'm going to write it as A plus negative B. Okay, so negative B will be going this way. Okay, so I repeat, for the first vector, the starting point, the ending point. The ending point of the first vector will be the starting point of the second vector, which is negative B. Okay, so starting point of the second vector, then this one is the ending point of the second vector. Okay, so your resultant vector will be using the starting point of the first vector, okay, at the starting. Okay, the ending point of the second vector will be the ending for the resultant vector. Okay, so it will form a triangle. Okay, so this is triangle law. Okay, now we go to parallelogram law. Okay, what is the difference in between triangle law and the parallelogram law? Okay, two vectors A and B initiated form the same point. This is different. Okay, just now you listen to me. You know the first vector, the ending point must join with the second vector, the starting point. That is the key for the triangle law. But for parallelogram law is the two vector must initiated from the same point. This is the key. Okay, means the vector A, the vector B, they start at the same point. Okay, can be represented by two sides of a parallelogram. Okay, once you draw it out already, the A and the B at the starting point, you have to assume that this A and the B are the two sides of the parallelogram, and then complete the parallelogram so that the diagonal of this parallelogram, okay, is the resultant vector. Okay, the resultant vector of A and B is the diagonal of the parallelogram AC. Okay, remember for a parallelogram there are two diagonal. Okay, don't choose this diagonal got no meaning. Okay, means that two vector plus the resultant vector, all these three are the starting point are the same point. Okay, so this is the key for the parallelogram law. Okay, so must be very clear about the triangle law and the parallelogram law. Sometimes you can use the triangle law, sometimes you can use the parallelogram law. Okay. Okay, now we come to this polygon law. Okay, polygon law, as I say just now, this is from the triangle law. Okay, so let us see. Okay, you see, first of all, you look at this two. Okay, if just now what I say in the triangle law, remember B and B, these two must be the same. So the end result from here, the first one, you will get AC. Okay, then the AC continue with the CD. Okay. Okay, again the same thing, you see. C and C the same, okay? So the resultant for AC plus CD will be AD. Okay, then continue plus this. So AD plus DE. Okay, D and the D the same, okay? AE. Okay, so this one will be the final answer for the resultant vector if you combine AB, BC, CD, DE. Okay, one shot you also can do. Just check B and B the same, C and C the same, D and D is the same. So your resultant vector will be the AE. Okay, the starting point of the first vector and the ending point of the last vector. Okay, AE. Okay, if by drawing the diagram A to B, okay, remember triangle law, the ending point will be the starting point of the second vector. Okay, B to C, C to D, D to E. Okay, therefore, starting is here, A, and then you go to this path, this path, this path, this path, and then at the end is this. Okay, if I say I want to do a shortcut, so it's from A to E. Okay, I want you to do this way. For resultant vector, it's better that you put double arrow. It's easier. Okay, to know that which one is the single vector and which one is the resultant vector. For this also the same. Okay, put double arrow. Okay, so easier to differentiate which one is the original single vector and then which one is the resultant vector. Okay, this one the same. Okay, this is a resultant vector. This is a resultant vector. Okay, this one the same. Okay, this is a resultant vector. Okay, put double arrow. Okay, so that's about it. Okay, for the trade law. After that, you have a few examples. Okay, then after that, you have a solve problem. Then that's it for the 8.2. Okay, let us go through the example. Okay, this is a parallelogram, PQRS. Okay, they want you to express PQ, okay, by using PS and SQ. Okay, so you see, PQ will be the shortcut lah. Okay, if you want to go a longer way, okay, so but must use this and this. Okay, so you can use P to S and then S to Q. P to S, S to Q. Okay, so it's PS plus SQ. Okay, here they write this is using triangle law. Okay, next. Okay, PR. Okay, P to R. Okay, by using PQ, PS. PQ, PS. Okay, so this is the parallelogram law. You see, 3 also start at the same point. Okay, so PR as the diagonal of the parallelogram will be the resultant vector of the two side vector, so which is PQ and the PS. Okay, so PR is equal to PQ plus PS, or the PS plus PR, the same thing. Okay, so this is parallelogram law. Okay, that's why I say you must good in parallelogram law, also you must good in the triangle law. Okay, next, QR. Okay, QR here. Okay, so this one will be the resultant vector by using PR. PQ. A little bit difficult, lor. Okay, maybe I don't write in this way. Okay, I don't want it to be this will be the resultant vector. Okay, I will do it another way round. Okay, so you see, PQ, QR, I will get PR. So I write PQ, QR. I will get PR. I write out this first. Okay. PQ, QR. Okay, so the resultant vector here actually is PR. Okay. But they request QR as a subject. Okay. So what I'm going to do is the PR I'm going to decide. Okay, so the QR just do like normal. Okay, this one plus being to decide will become minus. Okay, so this is the answer. Okay, PR minus PQ. Yeah, it's easier you do in this way rather than you think of this way. For me lah, okay. But also can, okay, you see QP, PR, and then after that only change the QP become negative PQ, also can. Okay. Okay, given that PQ is 2A plus B, PS is 2B minus A, express PR in terms of A and B. Okay, do we have something relate with PR, PS, PQ? PR, PS, PQ, this one, no? Correct? PR, PS, PQ. Okay, look at number 2. Okay, I'm going to use this. Okay, so the PS I replace with the 2B minus A. The PQ I replace is a 2A plus B. Okay, just do as normal. Okay, A with the A. So 2A minus A, you get A. Okay, B with the B. So 2B plus B, you get 3B. Okay. So this is example number 9. We go to example number 10. Okay, the diagram on the right show a pentagon ABCDE. Okay, given that okay, express CD in terms of A and B. CD. Okay, what is given in terms of A and B? The AB is in terms of A, and then the AE is in terms of the B. Okay, let us see one by one. BC. BC is 1/3 of AE. Okay, when you see this, you know already they are parallel. So remember, if and only if. Okay, the two vectors are parallel. Okay, so one of the vector can write as a scalar, the product of scalar with another vector. Okay, so when you see this, it's understood that the BC and the AE are parallel. Yeah, even though they didn't tell you in the questions, but they are parallel. Okay, if AE is B, BC is what in terms of the B? Okay, so BC is equal to 1/3. AE is B, so replace with B. Okay, therefore BC is 1/3B. Okay, write all these are small information on the diagram. Can, no problem. Okay, next the same thing. ED is half of the AB. Okay, AB is the A. Okay, so ED is the half of A. Same, ED and AB are parallel. Okay, because they can relate in this way. Okay, with a scalar. Okay, product of a scalar. Okay, now I have gathered all the information done. Okay, so now they want from the C to the D. Okay, this one you have to use the polygon law. Okay, from the C, so I go this way. Okay, C I go to B, B I go to A I go to E, E I go to D. But when you see C go to B, is different, is an opposite direction as this arrow. Okay, so you got to write negative for it. Okay, this is why the first one you get negative 1/3B. Okay, B to A the same thing, is opposite direction, so negative A. Okay, A to E same direction, so it's positive B. E to D same direction as this, so is positive half A. Okay, that's all. Okay, then combine. Okay, A with the A, so half minus 1. Okay, so negative half A. Okay, B and the B, so 1 minus 1/3 is 2/3B. Okay, this is how you get your answer. All this you must be very good, okay, even though it's simple, but you must do it very fast and very good in it, because the exam question is complicated, so you can't afford to make any mistake, especially with the positive and the negative sign. Okay, if you make a little bit small mistake, the whole things can be 10 marks gone. Okay, even though maybe you can get some marks for the working, it will be very, very poor marks. Okay, so you must be very careful with the sign for the vectors. In fact, for any questions, not only for vectors, for maths, and maths the same thing. Okay, now we look at example 11. Okay, look at this. This is what I give the example like just now, very, very early, okay? My first example. Okay, calculate the new direction and the velocity of the boats after affected by the river stream. Okay. Ayo. Well, very disturbed, the telegram. Come, we look at this. Means they want this. The new direction and the velocity. Okay, they want two things, direction and velocity. Okay, here. Okay, means they want the vector and also the direction. Okay. Okay, remember the directions that day I teach you already. You can use the bearing. Okay, the bearing is always start from the north. Here is the 0 and then come this way down. Okay. Okay, let us see. This is 10 and this is 5. Okay, just use the Pythagoras theorem to get the other side, which is the hypotenuse. Okay, so you just use the Pythagoras theorem, you get this. Okay, after that, the angle, remember the angle is always referring to the north. Okay, so you got to get the angle, this angle. Okay, this is pointing to the north. Okay, so the angle that you want is this. Okay, because you are now dealing with this resultant vector. Okay, so the angle that you want to find should be this. This one will be the bearing. Okay, remember the bearing, 3 digits. Okay, after that followed by a decimal if got decimal. Okay, decimal, 2 decimal places. Okay, so now how to get this angle? Okay, if this angle, this one will be the opposite. Okay, this one will be the adjacent. So you are using tangent. 2 O over A. Okay, therefore it's 10 over 5. Okay, this is how you get. Okay, then here for the theta, okay, the angle, you have to press the calculator. Okay, shift tangent. Okay, and then 10 over 5 or the 2. Okay, then you should get this. Remember, bearing is 3 digits. Okay, don't write just this one. This one got no meaning. Okay, unless you want to describe it if from the north to clockwise. Okay, if not, okay, you got to say bearing and then followed by this format. Okay, so please be careful. Make sure you know how to state the directions. Okay, so this is the example. Okay, now I think I can still go through this. Maybe I patah balik. Okay, I solved the problem first. I don't know where. Okay, let us see this problem. Okay, position vector. Okay, actually this position vector, you're going to learn again, I think in 8.3. Okay. Okay, so, but never mind lah. OA is given A plus B. Okay, OB is given as a 3A minus 2B. Okay, OC is given as a HA plus a 7B. Okay, let us see what is the next story. Okay, find the value of the H where these toys, car A, B, and C are placed in a straight line. Okay, means this one. A, B, and the C, okay, will form a straight line. This is the meaning. Okay, if this one will form a straight line, collinear. Okay, what you have learned yesterday, collinear. Okay, so collinear. What is the condition for collinear? Okay, one is they have common point, yes. The other one will be they will be parallel. Okay, for this I will put A, B, B, C. You can put A, B, A, C. You can put A, C, B, C. Okay, anything. Okay, try to delete these 3 points. Okay, so I will put this way. AB, okay, is equal to lambda BC. Okay, since they are in the straight line. Okay, so now I need to get AB and I need to get BC. Okay. I think the textbook they are using another way. They're using AB and AC. AB and AC. I'm using AB and BC. Okay. So I don't follow the textbook one. I want to do by myself. Okay, and then I see whether I can get the same thing as the textbook. Okay, so that you know that actually you can use a AB, you can use a BC, you can use an AC, and then choose either two to form these equations. Okay, so I start with AB. Okay, so AB, because this is a positions vector, so you do in this way. Involve with the O. So A to O, O to B. Okay, so you see or not? This is the resultant vector. Okay, now I write what can form this resultant vector. What is the path that I can take to form this resultant vector? AB, AB. In between, what must be the same? The common here is the O. So no choice, I choose O. Okay, but I don't have AO, I have OA. So AO, okay, is a opposite direction. So OA is A plus B, so AO is negative A plus negative B, or negative A minus B. Okay, or you can write in this way, AO as a negative OA, and then OB. Okay, so OA is A plus B. OB is 3A minus 2B. Okay, now expand. Okay, combine A with A. 3A minus A is 2A. Combine B with the B, okay, altogether negative 3B. Okay, I have done for the AB. Okay, now I do for the BC. Okay, same thing will be BO, OC. Okay, BC is here, BC is here. Okay, the common one, okay, I have only O. Okay, BO I don't have, I have a OB. So I write it as negative OB. Okay, OB is 3A minus 2B. OC as a HA plus 7B. Okay, expand it, negative 3A. Negative, negative become positive. Okay, now group the A. So I have H minus 3 for the A. Then for the B, 7 and 2 is 9B. Okay, after that, only bring into this formula or these equations. Okay, AB, I get is 2A minus 3B lambda. Okay, BC, I get H minus 3. I hope you are okay with the lambda. I think our physics use it. Okay, after that, remember for this type of questions, very important. You are doing comparison, okay? Comparison of, okay, vectors. Means here you have a vector A and B. You compare the coefficient of the vector A and you compare the coefficient of the vector B. Okay? Because always the student come to here, they shift here and there, they don't know what to do. Okay? Okay, so you see how do I do the comparison? Okay, bring in the lambda. Okay, so okay, now you see, okay, A with the A, the coefficient is 2 at the left and then this on the right, lambda in bracket h minus 3. This one means, okay, is equal to 2. Then compare with the coefficient for the B. Okay, on the left is -3, on the right is 9 lambda. Okay, so 9 lambda is equal to -3. Solve this one first because this one have only one variable which is lambda, but this one got two variable which is lambda and the h. After you get the lambda from this and then replace it into here, you get the h. Okay, so lambda will be -1/3. Only replace it into the first equation to get the h. Okay, what's the questions? Okay, find the value of h. Okay, so continue. Okay, -3. Right, my answer. Right? Okay, so this is for some problem. Now today again, you got a lot of exercise to do. Now we still have 20 minutes. Anything that I can settle with you now, then you don't need to do. Okay, we'll go through. Okay, so this one as a homework. Okay, this one, the answer. Okay, look at these questions. Look at these questions. Okay, from here you can get the speed. Okay, kilometer per hour. Okay, 2 hours is 1,200. 1 hour is 600. So this is the speed. Okay, the wind blow from west. Okay, this is another one. Okay, so this question you don't get mistake. Okay, because you see this. Read until finish the questions. They want the original direction of the plan. What's the meaning? Original direction. I'm also quite confused, no, this one. The velocity of the plane without the influence of the wind. Like just now, I use the example, you swim across. So that one will be your original. That one will be the without the influence of the flow. But this one, you see, they are asking the other way around. They are asking the original one. They are asking the velocity that without the influence of the wind. Okay, means this one is already the resultant. Okay, it means this way. This is the wind. Okay, that blow from the west. Okay, so from the west go to the east. Okay, then this is the resultant. Okay, that flying to the north, exactly to the north. This is the resultant. Okay, which is a 600 velocity. Okay, it means that the aeroplane, the original direction and the velocity is this. They're flying this way. Okay, then influenced by the wind, so it will end up in this way to the north exactly with the 600 velocity. This is what I understand now. Okay, if I'm mistake, then let us discuss our next lesson. You also go and see into it. Okay, so the answer at the back, I'm not agree with law. Okay, so the answer, if in this way, it should be this. Okay, so you write down, and then you check, is it what I say is correct? Okay, so this one is number 4. Okay, we try to do now number 1. Okay, the diagram on the right show the vector u and v. Draw and label the resultant vector of each of the following. Okay, I don't know how to ask you to draw, to do one by one. If I don't ask you to do, means you got to do by yourself. I will show you one how to do. Okay, I will show you this only. Okay, so the you have to do all this one. Okay, 2u plus v. Okay, how to draw it? This one, if you are using the line exercise book, you got to find the grid one. Okay, you got to draw on the grid and then cut and paste into your exercise book. Okay, if you want to draw the grid, a bit difficult lah. Okay, okay. So 2u plus v, okay, you see, 1u is here to here. Okay, so it's how to say, horizontally go to the right 4 units. Okay, so 2u will be double out, so will be 8 units. So it will be 4, another 4. Okay, so it's from here to here. I draw on top of it. Okay, so this is 2u. Okay, and then plus the v. Okay, plus the v, okay, so you see the ending point is here. So the v, you got to assume that this v you shift up. Here I got no space already, so I do again. Okay, because I want to make use of this grid, sorry, so I know that I need at the end here. Okay, so again, let's say the u, I start here, the 2u. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the 2u. Okay, so the ending point is here. Okay, so the ending point will be the starting point of the next one. The vector is v, sorry. Okay, v is how? It's a 3 by 3. Okay, so you got to count 1, 2, 3. Oh, cukup. Okay, 1, 2, 3. Okay, so continue. Okay, the ending point of the first vector is here, will be the starting point of my second vector. Okay, this is, I'm using triangle law. Okay, if you want to use a parallelogram law, also can. Okay, so this is the v. Okay, so resultant vector will be starting point of the first vector to the ending point or the terminal point of the second vector. So from here to here, use ruler, okay, draw double, okay, and label it 2u plus v. Okay, so this is A lah. Okay, but the B and the C and the D is more difficult. Okay, let's say we see what is difficult here. Okay, let's say the B. Okay, what is the half V? Okay, I erase already. What is the half V? Okay, if V just now, okay, we know already is 3 by 3. Okay, so half V will be half of this and half of this. Okay, so it's 1.5 and 1.5. It's so difficult, you see. If I draw it here, it's 1.5 and 1.5. This is the half V. It's so difficult, you see, in the middle somewhere. Okay, and then continue with the 2u. Then from here, you count 8. If not, easier way, terbalik. 2u do first. Okay, means you draw 8 to the to the right, and then only continue with this small tiny 1.5. Okay, it's easier. Okay, then what is the negative 2v? Negative 2v. Okay, so I roughly go through with you already. So I hope you can do it. Okay, these kind of questions usually will come out in paper 1 for the old format. Okay, okay, what is the negative 2v? Okay, you see, v is this way. Okay, so negative will be this direction. Okay, opposite direction. Okay, and then double up. So 3 by 3, you will have a 6 by 6. Okay, so it start from this corner will be 2, 4, 6. Okay, 2, 4, 6. Okay, so use ruler. Okay, and then this direction. This will be negative 2v. Okay, so your grid must be big enough lah. If not, cannot. Okay, what else is difficult? Okay, how about this? Okay, negative 3 over 2v. Very high. Okay, just now your half v. We take just now the half v. Okay, and then times 3. Okay, and then a different opposite direction. Okay, so many things to consider. Okay, so the half v just now is this 1.5, 1.5. Okay, okay, so 1.5, 1.5, 1.5, 1.5 times 3. So every of this 1.5 times 3. So it's how many boxes? Okay, 4.5. Okay, so this is 4.5 boxes. Okay, so you count 1, 2, 3, 4. 1, 2, 3, 4. 4.5. Aduh. 1, 2, 3, 4. 4.5. Aduh. Okay, so from here to here. This direction is positive. This is negative, so pointing down. Okay, this one will be your starting. This one will be your ending. Okay, ending, then continue with your 8 units. Okay, because 2u is the 8 units. Okay, but it's this way, 8 units. Okay, try to do lah. Okay, so this exercise you need to do. Okay, wait for a while. B, 是饼干，泡奶油。Okay. Okay, next exercise. Okay, this one. 2 questions here. I don't know whether I got time to go through with you this one. I still got 8 minutes. Maybe hold on for these questions. Hold on for these questions. Okay, these questions don't do yet. Okay, next lesson only we see these questions. Okay, then we go to another exercise. Okay, this one. Okay, this one also the same thing. You don't do question number 6. Okay, these 2 questions actually is the typical exam questions that will bring you 10 marks. Okay, so these 2 questions I want to separate out. Okay, I will discuss during the next lesson. I still have a bit more time. Maybe I can go through 1 and 2. Okay, express the following vector in terms of x and y. This one I can call one by one to do. Right? Okay, Sophie and Suchitra. Questions? And then 1, 2, 3. Okay, Valerie. Okay, each of you answer one questions. Okay. Start with Sophie. Sophie do A. Suchita do B. Valerie do C. Anyone want to on the mic? Can. Okay, express the following vector in terms of x and y. Okay, A is AC. Yeah, give the final answer in terms of x and y. Don't want the capital A, B, C that. Okay, x plus y, correct? Okay, that's simple. Okay, AC, this is using parallelogram law. Okay, so you see the 3, 3 also fall at the same starting point. Okay, so it's x plus y, that's simple. Okay. Okay, Suchita do B. Okay, so she say it's x minus y. Okay, let us see Q to R. Okay, so it's a Q to P, which is a opposite direction with the y, so negative y, correct? And then P to R is positive x, so correct. Okay, x minus y. Okay, let us see, look at C. Okay, where we say x plus half y. X plus half y. Okay, let us see how. Sorry, P to R. So she used P to Q, and then this way, Q to R. Oh, this one is involve more step. Okay, so you see here, P to R. P to Q is Y. Are you sure, Valerie? Okay, maybe. Okay, so you look at this QR. I cannot straight away get QR. I have to get QT. Okay, before QR, I need to get QT. Sorry, QT. Okay, so Q to T is a Q to R, P to T. Okay, is Q to T, Q to T, Q to P, and then P to T. Okay, Q to P is opposite, so negative Y. P to T is positive 2x. Okay, then the QR is half of the QT. Okay, so negative Y plus 2x. Okay, first one need more step. I use PTTR, okay, the same thing. PTTR, same thing, okay. Next, if I want, I think I better do this way. Okay, I write it out. Sorry. Okay, I will explain. Okay, see whether she get the correct answer or not. Okay, I think I will do again so that you all can have a clear idea, because this concept is very, very important. Okay. Okay, the question asking for PR. Okay, so I start over again. PR. Okay. If I follow hers lah, she says she used PTTR. Okay, she used a PTTR. Okay, so PT is 2x. Okay, TR. When TR, I have a problem already. Okay, but TR is a half of the TQ. You want to one shot, right? Also can. But you got to repeating the 2x and 2x and 2x. Okay, then TQ is a T to P, P to Q. T, P, P, Q. Why I use all this? Because this one only I have the info in terms of the x and y. Okay. Okay, then TP, T to P, opposite direction, so it's negative 2x. P to Q, okay, is y. Okay, so bring in the half, negative 1, and then half y. Okay, so 2x minus x is x. Okay, so is her answer correct? X plus half y. Okay, x plus half y. Okay, so correct. Okay, so I think that's all for today. Okay, so you do this. Okay, this one no need do. If you want to do, you can do C. Okay, A and B is too simple. Okay, then the rest you do. Okay, number 2 you do by yourself lah. For the following diagram, express PQ in terms of XY. This one you got to creative. How to play like a puzzle, Okay, how to puzzle out this X and Y. Okay, to form this PQ. Okay, sometimes also I quite slow in seeing this. Okay, go to the right, go to the left. Okay, go slanting or whatever. Okay, but try. Okay.